For days, Britain has been baking, temperatures climbed, parks filled with people searching for shade, roads shimmered beneath the summer sun, fields and landscapes dried out under persistent heat. And across the country, people waited for one thing: relief. Now, that relief may finally be arriving, but there's a problem. The weather isn't simply cooling down, it's changing. The blue skies can give way to towering clouds. The warm, stagnant air can be replaced by rapidly developing thunderstorms. And suddenly, the biggest weather story isn't the heat anymore, it's what comes after it. Because when a prolonged heat wave breaks, the atmosphere doesn't always transition quietly. Sometimes the change arrives with lightning, intense rainfall, powerful gusts, and rapidly changing conditions. So if Britain is finally escaping the heat, why are thunderstorms suddenly becoming part of the forecast? The answer begins with what the heat wave left behind. For days, the atmosphere has been dominated by warmth. Strong sunshine has heated the land, warm air has settled over large parts of the country. Temperatures have climbed well above what people normally expect during an ordinary summer day. And when that pattern lasts long enough, something important happens. The ground warms, the air near the surface warms, moisture can build within the atmosphere. And the difference between air near the surface and colder air higher up can become increasingly important. This is where the transition begins, because the heat doesn't simply vanish. A new weather system has to come in and change the atmospheric setup. Cooler air begins moving toward the warmer air, the pressure pattern changes, winds shift, and the atmosphere becomes increasingly unsettled. Think of it as the weather system being rearranged. One air mass is giving way to another, and when those different air masses meet, rising air can become much more important. That is where thunderstorms enter the story. A thunderstorm needs several ingredients: warm air, moisture, instability, and something to force that air upward. The basic idea is surprisingly simple. Warm, moist air near the surface rises. As it rises, it cools. Water vapor condenses. Clouds grow vertically. And if the atmosphere is unstable enough, those clouds can continue building until they become thunderstorms. That's why the end of a heat wave can sometimes produce a dramatic change in the weather. The heat creates one part of the setup. The incoming cooler air and changing weather system provide another. And suddenly, the atmosphere has the ingredients it needs for convection. The same transition that finally breaks the heat can therefore help produce the storms. But there's still a major question: where will those storms actually form? Because forecasting thunderstorms is much harder than simply saying, thunderstorms are coming. Look at a weather map of Britain. You might see areas highlighted for possible thunderstorm activity, but that doesn't mean every person inside that area will experience a severe storm. Thunderstorms are extremely localized. One town can receive torrential rain. A nearby town might see only a few clouds. Another location could experience lightning and strong wind, and just a few miles away, conditions could remain relatively quiet. That's one of the biggest challenges meteorologists face. They can identify the ingredients. They can monitor instability. They can track approaching weather systems. They can use radar, satellite imagery, weather models, and observations from the ground. But the exact location of every individual thunderstorm can still be difficult to predict. Tiny differences in temperature can matter. Humidity can matter. Wind direction can matter. Local geography can matter. The timing of the incoming weather system matters. A difference of just a few hours can completely change the outcome. And that's why a thunderstorm forecast is rarely as simple as a line drawn across a map. The atmosphere is constantly moving, and thunderstorms are constantly developing, weakening, and changing. Which means the next stage of Britain's weather could look dramatically different from one location to another. And there's another reason to take the transition seriously. The threat isn't just rain. When people hear the word thunderstorm, they often think about heavy rain and maybe a flash of lightning. But thunderstorms can produce several different hazards: lightning, intense rainfall, strong wind gusts, hail, and in some situations, localized flooding. The exact threat depends on the storm and the environment around it. A storm doesn't have to cover the entire country to cause serious disruption. It simply needs to develop over the wrong place at the wrong time. Imagine a thunderstorm forming over a major city during the afternoon. Millions of people are moving around. Roads are busy. Public transport is operating. Outdoor events are underway. People are commuting home. Then the sky begins changing. The temperature drops. Clouds cower above the horizon. The wind shifts. Lightning appears. And within a short period of time, conditions can become completely different. That's what makes thunderstorms so visually dramatic. The transformation can happen in front of you. Blue sky, then clouds, then darkness, then thunder, then rain. The atmosphere can change gears remarkably quickly. And after a prolonged heat wave, that sudden transition can catch people off guard. Because psychologically, people tend to think in simple categories. Hot weather means danger. Cooler weather means relief. But the atmosphere doesn't work that way. One hazard can disappear while another begins. Think about the moment the heat finally breaks. You've spent days dealing with intense temperatures. Then suddenly, the forecast shows cooler conditions. The first instinct is relief. Windows open, people head outside. Outdoor plans return. The oppressive heat finally seems to be over, but imagine looking toward the horizon and seeing a huge wall of clouds developing. The air feels different. The wind becomes stronger. Thunder begins in the distance. The temperature falls rapidly, and suddenly, the weather is changed from extreme heat to thunderstorms. That's the psychological trap. People may stop thinking about weather risk because the original threat has ended. The atmosphere hasn't become completely calm. It has simply moved into a different phase. And that distinction matters. The end of a heat wave isn't always the end of hazardous weather. Sometimes it's the beginning of a completely different chapter. Now consider where these storms could occur. Britain isn't empty countryside. Large populations are concentrated across cities and towns. There are major transportation networks, busy roads, railways, airports, outdoor workplaces, construction sites, parks, sports fields, festivals, and other events. A thunderstorm passing over an isolated area may create very different consequences from a storm passing directly over a densely populated city. That's why forecasters don't only care about the strength of the storm, they also care about where it develops. And one of the biggest concerns with thunderstorms can be rainfall. Not simply how much rain falls, but how quickly it falls. Imagine a normal period of rainfall. Rain arrives. It continues for hours. Water has time to drain. Streams rise gradually. Roads may remain usable. Now compare that with a thunderstorm. A large amount of rain can fall in a relatively short period. Drainage systems can struggle. Water can accumulate quickly on roads. Low-lying areas can flood. Travel conditions can deteriorate. And because thunderstorms are localized, the impact can be highly uneven. One neighborhood could receive a tremendous downpour. Another nearby location might barely get wet. That's why radar imagery becomes so important. Meteorologists can watch individual storm cells develop. They can see where heavy rainfall is occurring. They can monitor movement. And they can update warnings as conditions change. But even with all of that technology, thunderstorms can still behave unpredictably. A storm can strengthen, another can weaken, new cells can form nearby, and the area experiencing the worst weather can shift. So when the forecast mentions thunderstorms, message isn't simply take an umbrella. It means conditions may change rapidly, and the hazards can include much more than rain. Lightning is another important part of the story. A thunderstorm can produce lightning, sometimes repeatedly, as electrical charges separate within the storm. Lightning doesn't always strike directly beneath the darkest part of the cloud. That means the danger isn't necessarily limited to the location receiving the heaviest rainfall. Then there is wind. Strong thunderstorms can produce powerful gusts as air moves downward from the storm and spreads across the surface. That can create sudden changes in conditions. Hail can also occur in stronger storms when the atmosphere provides the right conditions. Again, not every thunderstorm will produce all of these hazards. That's important. The goal isn't to make every storm sound catastrophic. The goal is to understand why meteorologists pay attention when unstable weather develops after extreme heat. Because a storm can be relatively ordinary, or it can become much more disruptive depending on its environment. And that brings us back to the bigger atmospheric transition. Britain is moving from one weather pattern toward another. Think of it as a sequence. First, extreme heat. Then, a change in the large-scale pressure pattern. Then, cooler air begins moving into the region. That creates greater instability in some areas. Warm, moist air is forced upward. Clouds develop. Convection strengthens. Thunderstorms form. Heavy rain and other hazards become possible. And eventually, behind the system, cooler and more stable air can spread across the country. This is the satisfying part of the story. The thunderstorms aren't necessarily a completely separate event from the heat wave. They're part of the transition. The heat helps create the warm environment. The approaching weather system changes the balance, and the atmosphere responds. So the weather that finally breaks the heat can also be the weather that produces the most dramatic skies. But once the storms move through, what happens next? Eventually, the atmosphere begins settling. Temperatures fall, humidity can change, clouds begin breaking apart. Cooler air spreads into areas that had been under the heat. The oppressive conditions start fading. But again, the transition won't happen everywhere at exactly the same time. One part of Britain may already be cooler. Another may still be experiencing storms. Another could be watching the final thunderstorms move away. Weather systems don't respect political boundaries. They move according to atmospheric conditions. That's why the map can look completely different from one hour to the next. And that's also why the end of a heat wave should be thought of as a transition rather than an instant switch. The heat doesn't simply turn off. The atmosphere reorganizes itself. And during that process, thunderstorms can become the bridge between the two weather regimes. There's also a bigger lesson here. We often imagine weather as a simple progression. Bad weather arrives, then it ends, then everything returns to normal. But sometimes, the atmosphere moves from one hazard directly into another. Extreme heat can give way to thunderstorms. Thunderstorms can produce flooding. Flooding can disrupt transportation. And then cooler, calmer conditions can finally arrive. The danger isn't necessarily getting worse every step of the way, it's changing. That's the key. The heat wave was one threat. The thunderstorms are another, and the weather system connecting them is what explains the transition. So when Britain finally starts cooling down, that doesn't necessarily mean everyone can stop paying attention to the sky. In some areas, the most dramatic part of the transition may still be ahead. Now return to the image from the beginning. Britain under blazing sunshine, people searching for shade, dry landscapes, heat shimmering above roads. Then watch the sky change. Clouds begin building, the horizon darkens, lightning flashes, rain moves across the landscape. And suddenly, the country that was desperate for cooler temperatures is dealing with a completely different kind of weather. That's the strange thing about a breaking heat wave. The relief is real, but the transition can be turbulent. The heat may finally be weakening. Temperatures may finally start falling, but the atmosphere isn't simply switching off. It's changing gears. And for millions of people, the next chapter could arrive with thunder instead of sunshine. The important thing is not to assume that every thunderstorm will become severe. Most won't. But when forecasters identify the right combination of instability, moisture, and a trigger, they know the atmosphere has the potential to change quickly. And that's why the radar matters. That's why the warnings matter. That's why the forecast can change even after the heat wave appears to be ending. Because the weather doesn't always move from dangerous to safe. Sometimes it moves from one type of danger to another before finally settling down. The UK's heat wave may be breaking, but the atmosphere isn't simply cooling down, it's transforming. The heat was one chapter. The thunderstorms could be the next. And the real question now isn't whether the heat is ending. It's what the atmosphere does as it lets go.